Solars are needed to save money and to save energy. The light from the sun produces renewable energy, which provides us with clean source of power. The light is composed with particles of energy, also referred to as photons. With the help of solar panels, no greenhouse gas is released into the atmosphere. It is used for a cleaner, a much more simpler and easier way to produce all the amount of power we actually need. So for our plan, we decided to develop a much more efficient and cost-efficient way to power Marshall Fundamental using solar-powered energy. We will generate this energy using solar panels that will serve as a source of absorbing and distributing energy from the sun to the school's power grid. In order to ensure the plan's success, we intend to propose distinct locations on the school's campus in which the panel will have the most success in absorbing sunlight.
Our first location is the baseball dugouts. This is because there aren't a lot of trees or objects to cast a shadow onto the solar panels when they are installed. Additionally, the dugouts already have a very flat platform, so installing the solar panels will be fairly easy. The main reason we chose this place was because the sun hits directly to the dugouts all day long, so it will be able to generate a lot of electricity. We plan on installing light bulbs around the dugouts so that after school, when the teams are practicing, such as band, softball, baseball, and soccer, that after school around 6, when the sun goes down, there will be enough light being generated to be able to give them a safe space to continue practicing. The measurement of the north dugout is 510.25 inches in length and 83.5 inches in width. And the west dugout is 495 inches in length and 95 inches in width. Our second location are the tennis courts. This is because, like the dugouts, there aren't a lot of trees or objects to cast shadows onto the solar panels when they're installed. Our plan is to install the solar panels on poles, which will be aligned to the gates of the tennis court, and this location will be able to generate a lot of electricity, which will power light bulbs that will light the area, and as well as other small things that will not be connected to the school grid system. The measurement of a gate in the tennis court is 143.5 inches in height and 83.5 inches in width. Here we have our sketches. In the first image, as you can see, it's of the baseball field. We have our dugouts and we have drawn in where exactly the solar panels will be installed at. Additionally, as you can see, the sun will be hitting these solar panels all day, which will generate a lot of electricity. And the second image is the solar panels that will be installed along the tennis court gates. The solar panels here are installed on top of poles, and these solar panels will be able to generate a lot of electricity as well, considering that there will be more than just a few compared to the dugouts.
Data. The amount of kilowatts per hour used on the Marshall campus is 1,097,250 kilowatts per hour per year. The average amount per month is 91,437.50 kilowatts per hour. The average per day is 3,047.92 kilowatts per hour. The amount of electricity generated by panels per hour is 13.035 kilowatts per hour. Per day is 312.84 kilowatts per hour. Per year is 114,186.6 kilowatts per hour. Cost. The total cost of the electric bill for the Marshall Fundamental campus is $226,893.81. For the solar panels, each one costs $275. The dugouts require a total of 24 panels for a total of $6,600. The tennis courts require a total of 9 panels for a total of $2,475. The lighting equipment for both the field, dugouts, tennis courts, and the parking lot will be a total of $15,000. The total cost of the project is estimated to be $21,575.
Savings. The amount of savings acquired from using solar-powered energy is about $22,689.33. The amount needed to build the new lighting that we plan to build is about $21,575. This new lighting will cover all areas of the lower parking lot near the lower field where the solar panels will be placed, and which would be more beneficial to cars that are coming in and out, especially during the night when practices are over. Next, we have how they will stay clean. Most manufacturers recommend cleaning solar panels about 2 times a year to ensure their efficiency. One solution would be having the janitors clean them, but considering that it's short-staffed and how busy they are, and also the workload that they already have, another solution would be having the students clean them. And by cleaning them, they would receive community service that will help them graduate. And while doing so, they learn about how to work and how they work and why we need the solar panels. This may influence how students think about solar energy, and it takes roughly about $150 to clean the panels, but by having students clean them, it would cost nothing in labor. Solar panels can be cleaned by simply water, nothing too harsh because it can cause streaks on the panels.
With the installation of solar panels near the baseball field and tennis courts, we could provide sufficient lighting for the night. With this, we could provide a lot more night activities and sports. Even with the activities we have right now at Marshall, students have to sometimes go into the field in the dark, mainly during late practices. With the environmentally friendly energy we produce from the solar panels, we will add lighting to the field area underneath the dugouts and the lower parking lot. This will ensure the safety of the students from driving in the parking lots to playing in the field.